So why can you have two volcanoes that show such different personalities? Why can a volcano such as Kīlauea have an effusive personality that produces lava fountains and lava flows and an occasional lava pond that may stick around for a few years? While other volcanoes such as Mount St. Helens have explosive personalities that result in them losing their tops. And then there are other volcanoes that when they erupt, they have such massive eruptions that they produce huge craters and you can be down in them admiring the scenery and not realize you're in a volcano. There's the boundary 10 miles away in the distance. It's all about the magma. It's all about what's in the magma. All right, I had to put in a little bit of chemistry. So magmas have what we call network formers and network modifiers. You've got certain elements like silicon and aluminum that like to form complex structures and hang out together. You've got other elements like iron and magnesium that like to try to break up the structures. That in turn affects things like the composition of the magma. So we talk about magmas. We've got mafic, intermediate, and felsic. That's all about the relative amount of the elements. So mafic magmas have low amounts of silicon and aluminum and high amounts of iron and magnesium. Felsic magmas are just the opposite. Well, network formers, network modifiers. Network formers, silicon and aluminum, so you go mafic to felsic, the amount of network formers goes up, the amount of network modifiers goes down. That in turn affects how the magma behaves. There's this property that all liquids have. It's called viscosity. How much resistance is there to flow? High viscosity magmas have a high resistance to flow. Low viscosity magmas have a low resistance to flow. So Kīlauea has a low resistance to flow as its magma. It likes to run like water. Yellowstone, Mount St. Helens, their magmas don't like to move at all. That also can affect one other thing, how easily the gases are released. All magmas also have gases in them. If you have a low viscosity magma like Kīlauea, the gases are going to escape. As the composition changes to felsic, the viscosity goes up. Those gases don't want to escape. You take all that together, now you understand the personality of volcanoes. Kīlauea, mafic magma, low viscosity, gases don't build up. It flows easily. You get lava fountains and lava flows. Mount St. Helens, felsic magma, high viscosity, the gases are stuck around in the magma. You end up with an explosive eruption. But volcanoes can also have a split personality. Mount St. Helens, after the May 18th eruption, well, it continued to erupt for 6 years, but it had an effusive personality. It lost all of its gases, so the magma just oozed out to form a lava dome. You can also have volcanoes that show different personalities in the same eruption. 2010, Eyjafjallajökull in Iceland erupted. The beginning of the eruption was nice and quiet. Lava flows, lava fountains. The second part of the eruption was explosive. It was coming up through a glacier. It was erupting high viscosity magma. It shut down air travel between North America and Europe for 2 weeks. You can also have a different personality if that magma interacts with water. Water and magma don't play well together. So Kīlauea, in May of this year, water got in and interacted with hot rock, and you got an explosive eruption. That's the same volcano in 1924. You also have water and magma not interacting in a liquid form. So in July, lava flow from this effusive volcano flowed in the Pacific Ocean, interacted with the cold water. Lava and water don't play well. You had an explosion that sent lava bombs through the roof of a tour boat, injuring 23. So with all that, what is probably the most dangerous personality volcano in the US today? A lot of geologists consider it to be Mount Rainier. Mount Rainier in Washington State. It erupts the same type of magma as Mount St. Helens. It has steep slopes like Mount St. Helens. It has glaciers that can produce water, and it's close to Seattle. So when you want to deal with volcanoes, you need to understand their personality. Thank you.